This video will be reviewing over Raoults law. Now, Raoults law came about in the 1880s from a French chemist by the name of Francisco Marie Raoult, and he discovered that when a substance is dissolved in a solution, the vapor pressure of the solution will generally decrease. And this typically will occur depending on two variables: the mole fraction of the amount of dissolved solute present and the original vapor pressure. And when we look at this will work because the addition of the solute particles will fill the gap between the solvent particles and take up space. This means that less of the solvent will be on the surface and less will be able to break free to enter the gas phase. This results in a lowering of the vapor pressure. Now, Raoults law states that the vapor pressure of a solvent above a solution is equal to the vapor pressure of the pure solvent at the same temperature scaled by the mole fraction of the solvent present. And what we're going to do is we're just going to go through on this video and see how we would use Raoults law to solve various problems. In example 1 of Raoults law, we have 25 grams of cyclohexane. Now, its vapor pressure has been given to us as 80.5 torr. The mass from the periodic table is 84.16, and that's just the weight of the carbons and the hydrogens in the formula. And we have 30 grams of ethanol, its vapor pressure 52.3 torr, and its mass from the periodic table 92.14. These are both volatile components and they're present in the solution. What is the partial pressure of the ethanol? The first thing we will be doing is we will be converting our mass of cyclohexane to moles of cyclohexane. Now, that's a simple mass mole conversion. We have our given mass of cyclohexane times 1 mole of cyclohexane over the weight from the periodic table, and we get 0.297 moles of cyclohexane. We will do the same thing with our ethanol. We have 30 grams of ethanol times 1 mole of ethanol over the weight of ethanol from the periodic table, and we get 0.326 moles of ethanol. Now, to get the partial pressure of ethanol, we will take the moles of ethanol and divide it by the moles of ethanol plus the moles of cyclohexane, and we get 0.523. Now that we have the 0.523, we're going to take this and we're going to multiply it times our partial pressure that was set up in our equation, and we get an answer of 27.4 torr. Here we have a second example of Raoults law. We have a solution containing 15 grams of mannitol. The chemical formula for mannitol is C6H14O6. It is dissolved in 500 grams of water at 40 degrees Celsius. The vapor pressure of the water at 40 degrees Celsius is 55.3 millimeters of mercury. We need to calculate the vapor pressure of the solution, and we are going to make the assumption that mannitol is non-volatile. Now, the first thing that we're going to do is come up with the weight of water from the periodic table. So 2 hydrogens plus 1 oxygen, weights from the table, 18 grams. We're going to convert the grams of water to moles of water. So we look in our problem and we see that we have 500 grams of water. So 500 grams times 1 mole over the weight of water from the periodic table, and we get 27.78 moles of water. The mass of mannitol, C6H14O6, from the periodic table is 182 grams. We will convert our 15 grams of mannitol to moles. So 15 grams times 1 mole over the weight from the periodic table of mannitol, and we get 0.0824 moles. We will take the total moles, 27.78 plus 0.0824, we get 27.86. The mole fraction of water would be 27.78, which is right here, divided by the total moles, which has been the moles of water plus the moles of mannitol. Divided, we get 0.997. We're going to take this right here and multiply it times the vapor pressure, and we get an answer of 55.13 millimeters of mercury. Here we have example problem number 3. What is the vapor pressure of pure butane at 20 degrees Celsius if the partial pressure is 698 millimeters of mercury in a butane acetone mixture where the mole fraction of acetone is 0.577? Well, let's look at what we're given. We have our mole fraction of acetone as 0.577. This was given to us. We know that our mole fraction must equal 1, so our mole fraction of ethanol would be 1 minus 0.577, so we get 0.423. Raoults' law says that the pressure of the solution would equal the solvent times the partial pressure of the solvent. So we take our 0.423 that we had calculated times 698, which was in our problem. We get an answer of 165 millimeters of mercury. Here's a practice problem for you to solve. This is just like number 3. So try to solve the problem. The next slide will have the answer for you. And if you have any difficulty, review over how to solve problem 3 or come by my classroom for additional help. Now on this problem, we have a little bit of a twist added. Here we have density mentioned. So the problem is, what is the change in vapor pressure when 164 grams of glycerin, chemical formula C3H8O3, is added to 338 milliliters of water at 39.8 degrees Celsius? The vapor pressure of pure water at 39.8 degrees Celsius is 54.74 torr. The density of water at 39.8 degrees Celsius is 0.992 grams per milliliter. Now take this one step at a time and don't let the problem overwhelm you. First, let's convert our grams of glycerin to moles of glycerin. Now we have 164 grams of glycerin. When we calculate the mass from the periodic table of C3H8O3, we get 92. So we have 1 mole over the weight from the periodic table. Grams cancel, and we have 1.78 moles of glycerin. We need to find the mass of water. However, we are not given that information. We're given information about the density. Now we know that density equals mass divided by volume, and we were given the density as 0.0992 grams per milliliter. We were also given information about the amount of water that was used, and that was 338 milliliters. Again, notice that here we have our density, and notice that right here we had the milliliters of water. Now we will solve for x, and that will give us our mass. So we calculate our mass as being 335.296 grams. We'll now take this and convert it to moles. So 335.29 grams times 1 mole of water over the weight of water from the periodic table, and we get 18.63 moles. As we continue with our solution, we will take our 18.63 moles that we calculated from the previous slide for water. We will divide that by the 18.63 plus the 1.78. This is the moles of glycerin and the moles of water. and we get 0.91. Now our solution, our formula that we're using is P solution equals X solvent times P solvent. So our X solvent would be 0.91, and our P solvent is our pressure, and our pressure was stated in our problem above right there. And we get 49.8 torr. Now we are asked to find the vapor pressure. And to get our vapor pressure, we take our final pressure minus our beginning pressure. Now as we look at this, our final pressure was 49.8 torr, and our beginning pressure was at 54.74 torr. So we do just a simple subtraction, and we get an answer of negative 4.94 torr for our change in pressure. One final example problem. Calculate the vapor pressure of water above a solution prepared by adding 10 grams of lactose, chemical formula C12H22O11, to 82 grams of water at 338 degrees Kelvin, where the vapor pressure is 187.5 torr for pure water. The first thing we need to do is let's take this 10 grams of lactose and convert that to moles, and let's take this 82 grams of water and convert that to moles. Now I did the water first, so I had the 82 grams of water from the problem, 1 mole of water over the mass of water from the periodic table, and I get 4.55 moles of water. I took the 10 grams stated in the problem. The weight of C12H22O11 from the periodic table is 342 grams. So 1 mole over the weight from the periodic table for lactose. I get 0.029 moles of lactose. Now to calculate my vapor pressure here, I would take my 4.55 moles of water over the total moles, 4.55 water, plus, that's supposed to be a plus there, let's change that, plus 0.029, and that gives us 0.9936. Next thing we're going to do is take that 0.9936 times 187.5 torr. Remember that was in our problem up here. We have an answer for the vapor pressure being 186.3 torr.